So we were going to give a project update. So we're going to start giving that update at this point. Okay, so I will just go through and do introductions. Some of us are not the people on the top list, but in fact the bottom list. So I'm Eric Ernst, and I am from Intel.
I'm Jessie Frizzell. I work at Microsoft.
And I'm Wei Zhang from Huawei.
I'm Xu from Hyper.
And I'm John Olson from Google.
All right, with that out of the way. So what we've been up to, I wasn't going to give this slide, but essentially there was Clear Containers and RunV in the 2015 timeframe. Both had pretty good ideas, and we both really liked each other, and we kind of came together. And over the last few months,
I'm surprised why I used the heart.
Yeah. And now, just last night, in fact, we gave birth to Kata 1.0. So I guess that there was a lot to do since there were projects that have existed for a couple of years. And so the first thing we did was work on the really easy stuff. So in our design, we have some shim work on the host. We have a proxy for it. We have an agent running in the guest, which is actually going to create the containers. And we have a protocol that we could define on how all these talk together. So that was step one. It was a nice way to say, like, hey, we work together. This is really easy. Knock this out of the park. Get some CI going, and it's fine. And then step two was to get our existing runtimes to be able to use these components. And that was pretty easy as well. Step three was the hard part, where we had to look at our projects that we love so much and decide, how do we pick one of these or start over, or what we should do. And maybe, I don't know.
Yeah, and a couple of words. Actually, yes, the first step is pretty easy. Actually, the real work for the Kata containers actually began through the Danforth PTG in last September, and after that we have a meet in Portland with the Hyper and Clear Container team. And we soon decide to do the real merge, and after that we have another meeting in Austin, and the Intel teams and the Hyper teams and the foundation team, and we sit together, and then we have decided on the gRPC protocol and so many modules. That's all settled at that time, and also the first version of the proxy is written by one of my colleagues in one evening. Yes, that's approved. We have started work, and then we announced the project merge. After that, we do some work in the shim, the proxy, the agent, and that's really easy steps. And the hard stuff is about the runtime. We have much of the discuss, even debates on how we choose the architecture, how we do step by step. At last, we decide to use the work containers framework, and together we get the APIs from RunV side. So that's what we do. And finally, we got the current shape, the Kata runtime command line. That's based on the Clear Container team's work, and also get some features from the RunV back. Actually, the network hot plug for RunV is contributed by Huawei guys. Yeah, and they also move these features to the Kata containers. And also the Kata runtime is the underlying is also from the Clear Containers Word Containers framework, and we bring the API architecture of the RunV and re-implement the RunV APIs, sandbox APIs on top of the Word containers and make it become the new Kata runtime API. Yeah, and also the teams do many works on the integration with all the CRI runtimes. Yeah. Your turn.
This picture kind of sums it up a little bit, but some of it's not really accurate with reality. But really, the goal for the project is kind of I think of it as like 2 deliverables that we're providing to the ecosystem. One of them is an OCI compliant runtime. And that's very much exactly what Clear Containers kind of was, and some of what RunV had. On top of that, though, the other deliverable. Who's that? Nice. All right. The other deliverable is a nice CRI-friendly library. So if you look at all the different CRI shims, Shu did a really good overview of this and introducing what Fracty is. And this is the other deliverable that we see of this project. A lot of CRI native-like functions available into the project, so that way we could be consumed, or Fracty could consume us. I think it's the right way to say it. And that part we really wanted to have completed in 1.0, and it was a lot of work and a lot of hard work on the Hyper and the Huawei side and everything else. And I think that'll be 1.1, or we'll kind of look at as we talk about next steps. But particularly, I think a couple of features that we're looking at, particularly around network hot plug and volume hot plug.
Yeah.
In order to be able to facilitate really easily being used by an existing solution that's already being used, like Fracty.
Yeah.
And just I don't know. Did you talk about dirty laundry and this kind of thing, of just like what's easy and hard?
Actually, I'm just do some code work for the Fracty to support the current runtime APIs. It's not really very hard, but it consumes times. But at this version, because the volume hot plug is not available yet, so that's still under some refactor actually. Yeah, so there is a lack of some features for that. We hope we could have a full workable version with the 1.1. Yeah.
The only thing that I would kind of add is that like going through this process, this was the hard part, to figuring out what does this API look like, and it has been very, very, very helpful to have actual consumers who are using this in production or who have already solved this problem before. So like the Huawei and the Hyper side of saying, we would look at it and say, hey, we need this interface, and be like, they're crazy. I don't know why they need that. But then to actually have the use cases and fully understanding and make it really clear of, oh, this is very pragmatic and natural, and we need to get this in.
Yes, and actually we really deploy it in the production environment. So we have many lessons learned from the production, and actually we do many optimization in the sequence. We fully use the hot plug for it and use the block device instead of the file system sharing. So we could in the production we could start a container in VM for about maybe 100 milliseconds. So that's partly because we can leverage the hot plug feature of the VM and the runtime library itself. Without that, we cannot reach such a speed. Yeah.
I don't know what the next slide is. Okay. Yeah, this is stupid. Yeah.
You leave this page empty.
But realistically, depending on how people who start kicking things around, it could actually be 1.0.1. depending if we have quick, yeah, but that's how number lines work, yes. I don't know if anybody else, I'm tired.
Well, I mean, so I think I can talk about the demo that you gave earlier, which people may or may not have seen, but Eric demonstrated earlier that it's possible to get Kata running in a Kubernetes cluster with a simple kube control apply as long as you're using Cryo or Containerd. But that's that's very much this is a way that you could do this. Having more along the lines of best practices and kind of how people might integrate this into production environments is stuff that 1.0 being a sort of stable target with a known feature set enables talking about how this would fit into a production deployment and a production service. So that's what I see coming.
And I want to say we have collaborated with Hyper and Intel in a long time, and I'm very glad that we joined the community in the very first, at the very first, and we currently have put the runway into our product usage, and we also want to move the runway to the Kata runtime in the near future. So I think we will keep putting more resources to the community and help the community to make the community the Kata runtime and Kata containers better and better.
And we talked about the Fracty example of what.
Actually, currently the Fracty need very few work to support the Kata containers runtime, just because we are working on move all the depends the API depends in the Kata runtime. So that will be quite straightforward to support the Kata runtime lab in the Fracty, and even more like the session this morning I mentioned, we could do even better than the previous Fracty, and at least we could eliminate another gRPC call from the Fracty to previous Hyper-D, and we could merge the code together and leverage the existing Containerd work, maybe write into a Containerd plugins to make the Fracty used easily for the community. Yeah, and the runway to Kata runtime migrations that's pretty straightforward, because all the runtimes, all the CRI runtimes are supported. So that's just substitute some modules.
Yeah, I specifically for that one, looking at some of the hot plug type of features that I know you guys are very interested in Huawei, and essentially getting those in so that way you're fully enabled on the Huawei side is what I was thinking for that one. Okay. So the other kind of area that I'm pretty hyper-focused, at least on the internal side, is some more end-to-end usage of Kata. So 1.0 is released. I want real people to do real things with Kata now. I would say definitely very confident. I know the least about using real things on this stage. And that's where leveraging other people and really this could hit like a number of different areas. So maybe we can talk around about different areas where Kata could be used or where we could do more. I'm done talking.
I'm the one who added the undernested virtualization bullet here. So I added this because I spent a lot of time with the Kata folks yesterday getting it up and running on Google Compute Engine with nested virt. And I know we're not the only ones who have an environment where VMs are sort of our deployment vehicle of choice as your base primitive to build on top of. And Kata comes up cleanly there. Getting a Kubernetes cluster with Containerd was the longer part of my day. The kube apply or kube control apply for the Kata runtime just worked. And spinning up Nginx and guestbook examples and other things, works as advertised. So that was exciting to see.
Yeah, I could comment on that. So, I definitely was playing around with it on Azure. I don't know. I always choose a random one. Throughout this process, and even before when it was the clear containers, and just in terms of like the future of Kubernetes multi-tenancies, in terms of like building a SaaS on top of Kubernetes, if you have a trusted API on top of the Kubernetes API, which I would not say is trusted right now for any sort of multi-tenancy, it's nice to know that you can use then containers that are actually VMs if you want to do like obviously privileged operations and stuff like that. So yeah, it's the great thing about these that I found with just like using them in general is that, yeah, it just works out of the box like with actual services, which I don't know why that fascinates me, but it does to this day. And then also just the overhead in general is like super low. In comparison with different operating systems, nested virtualization, which I won't say like, but there's also Windows containers. It boots faster, so it's cool.
Yes, I a bit shy to share some advertisement here. Actually, we do use the virtualized container in the production, and we provide a container service based on formerly Runway, and that will shift to Kata containers later. And just during the past month, we have developed a new generation of our container service platform that's based on the Google Cloud and nested virtualization. And yes, although the bare metal give us some better performance, but the nested virtualization give us more scalable, because we could leverage the benefit from the Google Cloud and currently Google Cloud and later be Azure. Yeah, and also we have to do many metrics and test for the nested virtualization case for the Kata containers, and actually we caused some, I'll say many kernel panics for the Google Cloud instances, and some just want to actually we really received many some the mails from the Google Cloud support side. Your instance or has experienced some problem, and we know that's not your fault, and that has been fixed. I think what we have to do is to get both the nested virtualization support and also the other basic infrastructure better, and not only the Kata improved itself for the nested virtualization, we find a better tuning for that, but also for all the public cloud, they could improve their support for the nested virtualization. So you could expect that will be better in the later months. Yeah.
It's definitely new for us, relatively. But it allows you to scale down in a way that physical servers don't necessarily, which I think is one of the more powerful parts of it.
In some of over the last couple of days, I've talked to a few people. I have a bunch of cards from people who are interested in Kata in kind of in different ways. A lot of the time I kind of go and say like, hey, it's secure, it's great, everything's nice, it's just a container, like everything's fine, but like it is a virtual machine. It does have a custom, well, you could put a custom kernel in there. You could be running a custom kernel on a per node, well, not on a per node basis, on a per pod basis or a container basis. And I think that some people were kind of interested in that way. Some people wanted to run really old kernels, which we'll have to see how technically feasible this, we'll see. But also other people are saying we have brand new devices and we have out of tree drivers. And, you know, I really want to be able to use this somewhere. And I can't just have it on my underlying node. I want it part of the image that I'm deploying. And, you know, I talked to Mellanox about a similar kind of idea. So I think that this is another area where if you really care about the kernel version you have and particular features you want to add to it, they have to be out of tree for any reason, or you just haven't gotten upstream, or yada, yada. I think Kata is a really neat area, and I would like to be able to collaborate as a community with people like this as well. On top of, you know, if you're more of like a storage focused person or anything else. But basically, I just mean to say I really want to focus on real people wanting to use Kata to solve their problems and to really collaborate and make sure it does meet the needs that you have. And if it doesn't, then get to work really, really quick. Nice. Somebody added this. I like that.
I suppose since I'm the one who added it covertly to the slide. So this really goes back to what you were saying with end-to-end examples and understanding kind of people's use cases for this. I know in the Architecture Council meetings, there's been a lot of chatter about hypotheticals and about potential ways in which Kata could be used, use cases that it will support very well, use cases that would require some engineering effort, and kind of understanding from folks out there what they're doing with containers, where they're concerned, you know, where security is a huge deal, and you know what the constraints on the way they want to be able to deploy their workloads are would be informative for real workloads. You know, not my little Nginx showing Hello World and very pink guest books.
Yeah, I mean, I don't think, do we have things that we can throw to people for like motivation to ask? All right, first person to give us an example of how they want to use Kata gets a little sticker. I'm not sure how small that is.
Or you also, I mean, you could open a general question since we're about 10 minutes out.
Yeah, please, general questions. Like, I think that we didn't really showcase enough that we have a big backlog. For me, the success of the project from my standpoint, the more people we have contributing and using, the better it is, particularly in the contribution standpoint, like more variety of potential users. So I'm desperate to talk to you guys. I didn't want to say it, but I am.
I'll try to unfreeze the room. Is there a demo that could be made that shows more clearly the benefit of running workloads under Kata containers versus, because since you can run in parallel workloads that are untrusted and workloads that are trusted, we should find a creative way of showing the security benefit of running under Kata containers.
So I guess I can toss one out here, and Jess may have others as well, but in public, I guess actually any of the folks who run public clouds or work on public clouds probably have examples of customers bring all sorts of things to your cloud. One of the projects that we have at Google is a syscall fuzzing project called syscaller. You could run that inside Kata without necessarily posing a lot of threat to the host that you were running on, and you know, kind of have that be a workload that someone could bring to your cloud and say, well, we're actually okay with this. When you have a public cloud, security researchers, malicious folks, like actually malicious folks, they'll bring all sorts of things, and having that extra, you know, level of security there where you have no idea what the workload is. It's not just untrusted of, oh, we haven't audited the source. It's untrusted of someone brought this, and it's an opaque entity to us. is I think where it really starts to shine, especially when you have things like accelerators or GPUs that you want to pass through.
Actually, I have to think about some demo for that, but just looks that I'm not smart enough to do the exploits. Yeah, I just checked a CVE list for the kernel, and try to find if there is a easily demo for that. Actually, I find it's hard to become a security engineer. Yeah, we can got many CVE, and it said by this we can get the privileges, and I try to write some code, but it's not really easy. So I have asked some of my colleagues, and but unfortunately currently we cannot do the exploit demo now. But I think we could do that later, because I also asked some real security engineers to get some of their works. Some of them are really they even hack something like Tesla.
Yeah, I mean, we were talking about that before too, about we can make artificial ones to cause a panic, but it's hard to be malicious sometimes. But unless you're Jesse.
Yeah. So yeah, in terms of like actual container breakouts, like Maya said in her talk earlier, I haven't seen one in the wild, and I actually host a site that is trying to, but there will be more on that in the future. But in terms of like actual use cases for Kata, like I'm super excited about Kata, even though I do have opinions on sandboxing. So like I think in terms of any sort of thing that you need to turn off sandboxing for, obviously you want to use a VM at that point, because if you turn off the sandboxing, then you're pretty much, it's not like you can break out of a container necessarily then, but you do have access to more things and more information that you could use if you did have like, say, a CVE as well. Yeah, I definitely think that in terms of, say you want to run Docker and Docker, running Docker and Docker but actually in a VM would be way nicer than the way people do it today, which is very host heavy in terms of the host devices being mounted into the container and things like that. So in terms of CI, where a lot of people are using Docker and Docker for builds, this would come in huge play there. And then like the syscaller thing, that actually clones new namespaces and stuff for the agents, and you can't actually do that if you have sandboxing turned on in Docker. So that's like another thing where it would totally come into play. So like any sort of like operation that you're trying to do in a container that you cannot do without like additional flags that make things insecure, like I obviously see it there. And then just as an overall general use case, things like our ACI, where we're just running workloads, we run those in VMs internally now, but like it would be super nice, in my opinion, not that we're actually doing this, it would be super nice to pop that out with like actual lightweight VMs, but yeah.
Yeah, I think thinking about the Kata containers, I think it not only it can bring us the security, but also it makes the deployment so easy. As a cloud provider, so Huawei, a new cloud provider in China, and we also provide the native container service. And every time when user try to buy a container, we force user to buy a virtual machine first, because due to the concerns, security concern of the native container. So thinking about the Kata containers, after we create a new service named container cloud container instance, the deployment will be so easy. Since then, every time the user buy a container, it's the user only need to specify CPU and memory, then everything and other resources, then everything is done. So they don't need to jump to another page and buy a virtual machine and then jump back to buy the container. So I think that's another benefit of the Kata containers.
Both these mics should be on for questions too, if you guys want to. People should feel free to jump up and ask questions if they have them.
So, a question on architecture, and maybe you can talk also about plans for the future. How do you sandbox the QEMU that runs on the host, and are there plans to use anything from namespaces to SE Linux to do more of containment of QEMU? Because, I mean, at this point, it's probably just as hard to break out of QEMU than out of KVM, because both of them have been audited nicely. But okay, if you break out of KVM, there's not much that you can do. It's game over anyway. But for QEMU, there's a lot that you can do. So are you doing anything? And if not, what are the plans to do it?
If anyone wants a sandbox, I'm pretty good at that.
Yeah, that was for you.
Oh, really?
Just kidding.
I don't know the plans, though.
Yeah, I don't. I even you brought it up briefly before, and I was like, this is something to look at. Yeah.
I'm not quite sure I understand the question.
Like putting QEMU into like basically namespace C groups and then locking it down with the policy.
Anything from devices, C groups to SE Linux policies, whatever.
So they're on the host. On the host, the thing that's executing the hypervisor is also in the same sandboxing.
You mean we do too many layers?
No, we don't do enough. The question is, should we add one more layer on the host so that we were running QEMU inside of this namespace as well?
So I want to share more. Actually, in our product, we didn't put we don't put the QEMU in the namespace, but we put it in a standalone additional C group. So for the resource limitation. So because this is we have a very special need that we need to allocate less than, for example, the 0.5 kernel CPU for the container or for the pod. So we need to host the group to limit it. So the QEMU can have one vCPU, but the C group, we only allocate 0.5 for it.
These are all things that, for example, Nova seems to run OpenStackHands-on. It's for free because they use libvirt. So libvirt does C groups, it does mountain spaces, I think. It does SE Linux labeling. So I know that there's the focus on boost time and all that for Kata containers, but still, for everything that you optimize, you risk losing something else.
Yeah. Actually, yes, libvirt do this, and actually we also use sometimes we use the libvirt as a driver for the run-v actually. Yeah, we use because it's a bit easier to use the libvirt to have some of the QoS control and that's make the rule to set the C group easier actually.
Are there any plans to use libvirt as driver in Kata?
It could be in the roadmap because we will make the hypervisor part very pluggable, but yeah, and sometimes because the libvirt itself, we always need to bump to the version for libvirt, and sometimes the libvirt have not enough features for the right new QEMU. So we in our new system we use the QEMU and plus our own policy against the Kata containers. Yeah.
Pluggable hypervisors have definitely come up, and writing a libvirt driver is feasible. One other place that I think that's probably relevant is Kata can ship with a static QEMU that's a, kind of, this is vendored and it's part of the Kata distribution, but being able to take advantage of system QEMU where people have, this is part of their particular distribution and they want to use the thing that shipped with their distribution and have as few vendored things as possible is another place where I think that becomes valuable.
Yeah, and more actually the CRI of Kubernetes have interface to online adjust the results of the containers of the sandbox. So we do have some concern to add it in the roadmap for the next version. So maybe from the operate on the role hypervisors and C groups namespace that makes things easier. Yeah.
Any other questions?
Yeah, maybe this is a naive question, but when you're doing storage in a Kata container, like in a traditional container host, if you were doing like a PV, like a persistent volume, you might have like a kernel driver mounting like a distributed file system, or a kernel block driver, mounting a block device in that container host. In that container host. In Kata container, if it's running in QEMU, you could potentially use like, can you use like VirtIO devices, like, or pass a distributed file system through VSOC or something like that?
Actually, for the PVs, there has many issues on the PV usage. In short, if you use some volumes from the distributed storage systems, such like the Ceph RBD or some NFS, you'd like to plug them into the QEMU directly instead of mount the volumes inside the host and then pass it through your IP to the VM. That's evil. So we for us, firstly, we in current implementation we do a flex volume in the Kubernetes. So we can bypass the volumes from the Kubernetes management to our own code. So we can just plug the volume into the QEMU, and later we are working together with CSI to cooperate with them to make that a bit standardized interface to and easier integrate all the volumes, maybe not all the volume, but the persistent volumes could be inserted to the VM in a better way. And there is another issue about if you implement it in a multi-tenant environment, then different volume may belongs to different users. There need another level of the authorization for the if the container or if the sandbox should have the access to the PV. That may need more engineering work for that. But if you are a service provider, that's worthy for you. Yeah.
Thanks. That answers my question.
And I think with that, we are out of time. So thank you very much to the Architecture Committee for answering people's questions. I don't know if you guys want to plug contributor onboarding, any of that. I think
we're
okay.
Up.
So anyway, there's a contributor onboarding Thursday, 4:40. We'll talk about it we'll meet. It's actually just across this hall in the Lightning Talk Theater. So if you're interested in contributing, we'll all be there to talk a little bit about how we work and good ways to get started. We are also having a little toast to the Kata Containers, all the contributors, a thank you happening in 2:17 immediately after this session. So please join us there. Thank you.